1941. The world was at war, and it was time for the next new engine technology to change the world. Enter the jet.
Jet engine is a gas turbine where you throw the exhaust gases fast out the back end to provide thrust, and the compressor and turbine of the gas turbine do the compressing to give you the high flow you need to throw out, and the turbine provides the work to drive the compressor, and what's left is what you use for thrust.
Imagine if you're baking cookies. Imagine if you bake the cookies one at a time. You put some dough on a tray, you shove it into the oven, you wait for it to bake, and then you pull it out. That's what we do in the internal combustion engine with the reciprocating piston. We put the fuel mixture in, stop. We compress it, stop. Burn it, expand it, stop. Push it out, stop. It's constantly stop, start, stop, start. Whereas with the jet engine, it's basically like a continuous process. Imagine putting all your cookie dough on a conveyor belt and running it through an oven.
It all started about 60 years ago when Britain and Germany were racing to develop the first ever jet aircraft. In 1941, Germany was the first into the air with a fighter prototype, the HE-280. A year later, the Germans had an even better jet fighter, the Me-262, and that was the world's first jet plane to go into mass production. Britain's first jet, the Gloucester Meteor twin-engine fighter, had its first test flight in March of 1943. From there, we've come all the way to this. Airbus Industries is developing what some are calling the Super Jumbo. It's a double-decker plane that's 50% bigger than a Boeing 747, and it's capable of carrying 600 or 700 passengers. In the early days of their development, rocket engines and jet engines were closely related, and people made little distinction between them. A rocket is similar to a jet, except that it carries its own supply of oxygen to create combustion. Jets get their oxygen from the air. Rockets get it from the oxygen tank they carry on board. That means a rocket can fly in space where there is no oxygen. Robert Goddard's rocket experiments in the United States in the early 1930s were followed by Werner von Braun's rocket experiments in Nazi Germany, which led to the V-2 rockets, which rained down on Britain during World War II.
We knew that we had created a new means of warfare.
The rocket technology pioneered by Goddard and von Braun enabled future developments, like the breaking of the sound barrier by Chuck Yeager in 1947, the launch by the USSR of Sputnik in 1957, and the Apollo 11 landing on the moon in 1969. Today, the three main rocket engines that power the space shuttle produce thrust equivalent to 37 million horsepower. That's as much as 23 Hoover dams. Together, the engines consume 64,000 gallons of liquid hydrogen fuel per minute. The engines are movable and are used to steer the shuttle during flights. They also provide additional thrust for launch, supplementing the two huge booster rockets which are jettisoned after takeoff.